This beautiful image, taken by the NASA ESA Hubble Space Telescope, shows the galaxy cluster MACSJ1149 This image has been following me since March 2015, and man, it contains some amazing discoveries. Multiple exploding supernovae, cosmological predictions, and the most distant star ever to be seen. Let's have a look. Hubble is best known for its spectacular images of stunning galaxies and beautiful nebulae, and also for its deep fields, where it stares as far as possible into the cosmos. The first one was taken during Christmas 1959. The resulting image consisted of 342 separate exposures, with a total exposure time of more than 100 hours, compared with typical Hubble exposures of only a few hours. The results are astonishing. Almost 3,000 galaxies were seen in the image. But the astronomers wanted more. After a servicing mission, which provided Hubble with new instruments, we repeated the experiment in 2004 and created the Ultradeep field. This time, we combined an exposure time of 11.3 days. The final snapshot showed us 10,000 galaxies of various ages, sizes, shapes and colors. The smallest, reddest galaxies, about 100, are among the most distant known, existing when the universe was just 800 million years old. While other deep fields followed, studying the universe in the infrared and the ultraviolet, Hubble had reached its limit on how far it was able to see. Well, till clever astronomers decided to use a cosmic magnification glass for help. The Hubble Frontier Fields program was born. This 3-year program created the deepest views of the universe to date, combining the power of Hubble with the gravitational amplification of light around 6 different galaxy clusters to explore more distant regions of space than could otherwise be seen. The gravitational force of these clusters is so enormous that they affect the region they sit in and distort the very fabric of the surrounding space. In space, light travels along straight lines, but in a curved space, the shortest distance between 2 points may not look particularly straight to us. Now what it means is that when light passes very near by a massive object that curves the space around it, the light ray is bent. As a result, this massive object, or rather the curved space around it produced by its gravity, acts like a lens. A gravitational lens that deflects light into our telescopes that would have otherwise never made it there. A gravitational lens not only makes images of background sources brighter, it also magnifies them. Exactly these effects can be seen in 6 galaxy clusters studied as part of the Frontier Field program. And one of these observed clusters is of particular interest, MACSJ1149 a cluster over 5 billion light years away. The first thing the Frontier Fields team recognized was that one spiral galaxy was visible no less than 3 times due to gravitational lensing. On a second note, they discovered something even more remarkable. Due to sheer luck, a supernova was exploding within this galaxy, and it was visible 4 times. This phenomenon was caused by an elliptical galaxy within the cluster acting as a second lens, deforming the one spiral arm in which the supernova was exploding. Being lensed twice, the supernova appeared 20 times brighter than its natural brightness. The supernova, nicknamed Refsdal, to honor the Norwegian astronomer Sigurd Refsdal, who in 1964 first proposed using a lensed supernova to study the expansion of the universe, gave the team the unique chance to refine the estimates on the amount and distribution of dark matter in the lensing cluster and galaxy. After the astronomers refined their mass distribution models for the cluster, they were able to do something extraordinary. They were able to predict the appearance of another supernova. The 3 images of the spiral galaxy which host the supernova do not arrive at the Earth at the same time, because for each image produced, the light takes a different route. Each route has a different layout of matter, both dark and visible, along its path. And so, for some routes the light takes longer to reach us than others. The used models assumed that the first supernova image appeared in 1998, an event not observed with any telescope. The second image produced the 4 copies, which were seen in November 2014. And on 11 December 2015, while Hubble was routinely scanning the cluster for the last appearance, the third image of the spiral galaxy showed the supernova exploding as well, as correctly predicted. It was an amazing experience to work with Steve Rodney, Thomas O'Troy, and Patrick Kelly, the masterminds behind this prediction, and to experience their joy and happiness. But the story doesn't end here. Steve and Patrick kept observing the fading supernova to study it further, and in spring 2018 they called me again as they noticed something else: the appearance of a single distant star. Like the Refsdal supernova, the light of this distant star, they soon called Icarus, got magnified, making it visible for Hubble. And well, how it was magnified! It was brightened 2000 times. And this magnification was needed as the light from Icarus came to us from the early universe, 9.4 billion light years away. Icarus turned out to be a B-type supergiant star. These stars are extremely luminous and blue in color, with a surface temperature between 11,000 and 14,000 degrees Celsius. The source of the strong magnification is unclear. It could be a stellar mass black hole or a neutron star, passing between the star and Hubble at the right time and the right distance. Does the story end here? Of course not. Observations made in October 2016 suddenly showed a second image of Icarus. This was actually an image the team expected to see in the first place, but it seems that there was yet another object in the line of sight, blocking the magnified light of Icarus from reaching Hubble's mirror. Is this now the end? Well, for now it is. But we should keep a close eye on MACSJ1149. It's full of surprises. Stay tuned for the next episode of Star Stuff.